Hello, thank you for coming here this morning. My name is Joe Darcy. I work in Oracle's Java Platform Group, and I'll be speaking today about JDK 9 language, tooling, and library features. There's a lot of material in the talk today. If we don't have time for questions at the end, you can tweet your questions to the hashtag here shown on the first slide. I'll also be tweeting a link to a PDF of the slides after the talk. This is a very important slide from Oracle's legal team. They want you to know to not trust very much what I have to say here today. They call this the safe harbor statement. However, as one developer to another, if you're interested in safe harbors, there are many other safe harbors in the area we could talk about. So I'm happy to share some tips on those after the talk. Quick survey of the audience of which JDK trains you're using in production. JDK 9 early access with Jigsaw, cutting edge Jigsaw. Any hands there? Well, about the other JDK 9 early access builds, some people have downloaded them. That's good. Perhaps a few more of you will download this after the talk. JDK 8. So most of the audience using JDK 8. It's very good from a few years back. People still on 7. Maybe a quarter of the audience for 7, still solid release. 6. A few more hands there. And admit it, it's OK. We're all friends here. JDK 5 or earlier. All right, a few brave people do admit. Well, there are many new features since then. Perhaps you'll be able to get motivated to upgrade by the end of the talk. Quick overview of what's in JDK 9. JDK 9 has been in development for a number of years, and the ship date for the general availability is coming up in a few months in July. As I mentioned, there are early access binaries for 2 lines of development. Both the mainline one and one with Jigsaw features that's a little more cutting edge. JDK 9 is being developed under the auspices of OpenJDK. So there's a project for that. There are various mailing lists. You can get the source code if you're interested. There's also various adoption groups. One of the initiatives we expanded for JDK 9 was to reach out to various open source projects to have them use the JDK 9 early access builds along the way so we can get more feedback about what's working well and what's working less well. Throughout the rest of the talk, I'll be using the term JEP. These are Jdk Enhancement Proposals, and they're a process we use to manage feature work now in the JDK. And Duke needs you, yes, you, to download these early access builds, try them out in your CI systems, and let us know what's working and what's not. We are fairly far along in the cycle for JDK 9. We're in one of the ramp down phases, but there's still time to send us some feedback and let us know how it's going. Capsule Summary of Jdk 9. The largest feature in Jdk 9 is modularity. This has been in progress for a number of years under Project Jigsaw. And modules bundle together multiple packages and offer stronger encapsulation than jar files. Earlier in this week, there have already been a number of DevOps sessions about modularity, which you may have already seen. This is a very large change. It's a language change and a larger change to the platform. There's a new kind of Java file, a module info file that allows the dependencies between modules to be declared. javac compiles those files. Then at runtime, the Java commands also been updated to enforce the same kind of dependency restrictions declared in the module info files. There's various other supporting changes as well, such as in core reflection and the language model API. As a large language change, it did affect many parts of the platform. Project Lambda in JDK 8 was also a large language change. However, the modularity changes in JDK 9 are somewhat bigger in the sense that they address the programming model more fundamentally. With modules, you're able to program in the large at a different granularity. So you have different questions to consider when you're designing your application or library in terms of what the module boundaries are, not just what set of types you might have. There are other JDK 9 related talks at Devox. There are some early in the week. My colleague Uriel gave a talk yesterday about the sharp edges of Jdk 9. I like to think of this talk today as covering not only the sharp edges, but also some of the rounded corners. Personally, I prefer the classic OG profile as shown here. There are a number of other Jdk 9 related talks later today as well. I'll just highlight 2 of them now. Trish Gee later this morning is going to be talking about tooling support in IntelliJ for Jdk 9. And this afternoon, Minaj Plot is also going to be talking about the Eclipse support for Jdk 9. With modern development, of course, it's not just about the support for the language feature that ships in the JDK. We also want to have good support in tools such as IDEs. Outline for the rest of the talk, I'll give a brief discussion of the stewardship philosophy we use in the Java platform group toward evolving Java. Just give some sense of the size of JDK 9. JDK 9 is a very large release in terms of number of bug fixes. This is a graph comparing the JDK 9 bug fixes per build to JDK 8. And we've had a higher fix rate in 9, and the release has gone on for longer. We're starting to level off now. This is from a week or two ago. So there are a lot of good changes in JDK 9. Those changes span a number of areas. There's tooling improvements, language changes, and library updates. Sometimes the features are well delineated into these buckets. Sometimes they cross over, so this is just a rough outline of the rest of the talk. And if we have some time at the end, I'll take questions and answers. Stewardship. The approach we use to stewardship for Java is not the same approach that we use, say, by Denethor in the Lord of the Rings films. We have a more benign and supportive view of stewardship for Java. Under the last 7 years under Oracle, there's been a consistent top priority for the Java platform group, which is to keep Java vibrant. Part of keeping Java vibrant is keeping things that work today working tomorrow. And that brings us to a discussion of compatibility and the general evolution policy we use for Java. And that general evolution policy for compatibility is we don't want to break binary compatibility as defined in the Java language specification. And what that means is we want to keep programs that link today linking tomorrow. We want to avoid introducing source incompatibilities, and we want to manage behavioral compatibilities. So this extends to language evolution as well. It means that we want to continue to recognize old class files, even all the way back to those version 45.3 class files from JDK 1.0. We want to limit the cases where currently legal code stops compiling. And we want to avoid changes in code generation that introduce behavioral change, surprisingly. And we don't just want to keep everything the same, because then there'd be no progress. So there is a balancing act between stability and progress with the recognition that there is a lot of value in good compatibility and keeping things working. So we've talked about there's 3 dimensions of compatibility: source, binary, and behaviorable. So we could view those as defining a little vector space, like you might recall from a physics class. And we have different policies about compatibility for the different kinds of releases we have. So for instance, if we have the quarterly security updates, those have a very small region where they can make incompatible changes, say recognized by this box here. We want to have some behavioral change. After all, if there's some bad code that we want to stop working, we want that to stop working. So that would be incompatible for an exploit, for example. And maybe there's a little bit of source code incompatibility we allow. For a larger update release, say 8U20 or 8U40, there's more fixes going in, more features, so we'd have a larger region we allow there. But in both cases, we stay in the source behavioral plane, meaning there's no binary compatibility change that we allow, because we want people to be able to easily update to the update releases without having to worry about their program stopping to link. The situation's a little different for platform releases like JDK 8 GA and now especially JDK 9. We have a larger compatibility region to play with, more behavioral change, more source code change, and with enough justification, even some binary incompatible changes. And we'll see 1 or 2 examples of that later in the talk. So a good example to help illustrate this different kinds of behavioral change policy, we can look at the specification of hasset.iterator. It says here, you get back an iterator, and the elements are returned in no particular order. That means if your program relies on the order, your program's kind of buggy. It also means that we are allowed by the specification to change the order, but that doesn't mean we always change it. So what is the compatibility impact if we did change the hasset.iteration order? Well, first, it's binary compatible. The set of methods isn't changing, so there's no concern there. It's also source compatible for the same reason. It's not going to change how your code compiles. However, it is this third kind of change. It is a behavioral change. And we know people can and do implicitly rely on the iteration order. We even have some examples of this in our own JDK code base that bite us from now and again. Therefore, this kind of change, changing hash set iteration order, would generally be out of bounds for an update release, but it would be something we could do and have done in a platform release. And we do this, say, to take advantage of better hash algorithms that are developed over time. So if you want to learn more about this for a particular release, you can look at the release notes and compatibility guides. They do use this source binary behavioral classification. This document was produced along those lines for JDK 8, and within the next few months, there will also be a similar guide produced for JDK 9. So how is JDK 9 different? As I mentioned before, it is allowing a larger range to make incompatible changes, and this is to further the long-term evolution of the platform. There are some things we haven't done before. So for instance, if you relied on the existence of rt.jar for some reason, that file is no longer there. One of the cases where we broke binary compatibility involved some unfortunate use of the Beans API in far-flung parts of platform, say in Java util. Java util jar, that's part of the base module. We want to be able to keep the base module nice and small, but in a few cases, it used part of the Beans API, which pulled in all the desktop module. So we didn't want to have the base module include all desktop as well. So the solution to this was first to deprecate these methods in 8 with the warning they'd be removed in 9, and now we've gone through and removed them in 9. So that is a binary incompatible change. If you relied on these methods, they're not there anymore. However, we thought it was important enough to have a better module decomposition of the platform to make that change. And if you're interested in deprecation matters, we'll be saying more about that later in the talk. And I encourage you to follow Dr. Deprecator, who takes care of Java compatibility, Java deprecation on Twitter. On to some of the tooling improvements. First up is JShell. In the Lisp community, there's been a long tradition of providing a read, evaluate, print loop called a REPL as a way of interacting with the language. If you, coming from the Ruby or Python community, you have similar functionality there. And on the VM side, if you've worked with Scala or Groovy enclosure, there's also this kind of REPL you're used to. So what about Java? Wouldn't a REPL be nice for Java as well? We thought so too, and that led to the JDK 9 project of adding JShell. And I'll give a quick teaser demo of that here. And that is not the window I want. OK, so this is JShell. It's a new command in the JDK. This is JDK installed from a recent JDK 9 early access. So we'll wait for that to start up here. So what's the first program you write in any language? Hello, world. So we can, excuse me, type that here. Now we see it comes back right away. So we executed our first JShell program. So this is just echoing the string back to us, but you'll notice we didn't have to say public static void main, string, arg, so forth. So there's much less ceremony to get started here. We can just start playing around. We can also say declare variables. So let's say we want to have a double variable tau, and we want that to be equal to 2 times pi. So we know there's a pi constant defined in the math class. We can tab complete for math here, and then we know that pi constant's there, so that auto-completes. And then we get that back to us. Of course, we don't want just fields. We also want methods. So let's say we want to define a method square that takes a double and squares it. Now this method's in our environment, so we can complete on that. And we can square tau, and we get back something that's about the right size. So that's good. There's also command line editing. So if we want to, say, take the square of the sine of the value and add it to the square of the cosine, we should get something close to 1. And that is indeed what we get. So going back to the slides. So as I mentioned, there's less ceremony for students getting started in Java, you don't have to worry about what public static void mean on the first day. But this isn't a feature just for people new to Java. It's also a useful tool for experienced developers. This might be a good way, for example, to start experimenting with those new and JDK 9 library features. The implementation of JShell leverages many existing JDK technologies. And the lead engineer for JShell, my colleague Robert Field, will be giving a talk about this later today if you're interested to hear a lot more about it. Next up, we'll talk about Javadoc. For many years, Javadoc output was done to the 4.01 HTML standard. A few years ago, there's a new HTML standard, HTML5. So now you can opt in your Javadoc output to be HTML5 instead of HTML 4.01. Although we don't have any videos enabled by default. How many people have used doclet from JDK 8? No hands. Well, if you're concerned about the semantic and syntactic correctness of your Javadoc, you can now check that using doclet either as part of javac or as part of the Javadoc command. One of the changes to doclet, one of the improvements we added in JDK 9 was package filtering. So for instance, in the JDK build, we only doclet the Java and Java.x packages and don't bother worrying about the Javadoc correctness to the same degree for the implementation classes, say in JDK.star or sum.star. The Javadoc checks, you can enable or disable these individually. They range from things from syntactic well-formedness of the HTML to semantic checks to make sure your etc and link tags have valid targets. If you write doclets, we've updated the doclet API to have a better foundation. The old doclet API was done very early in the Java platform. I think it's fair to say it didn't follow what are now considered best practices for API design. And we were able to re-implement this on a more recent language model and reuse that from another part of the platform. Another feature we added to Javadoc is a Javadoc search box, and we'll have another quick demo of that. Okay, so this is the Javadoc output for a recent JDK 9 build. You'll notice the frames view is no longer the default with those 3 panels. If you still like that, you can get it from over here for frames. And now in the upper right-hand corner, there's a search box. So let's say we want to search for math. We see here the search returns results in different areas. It searches over the names of packages, the names of types, and the signatures of fields and methods. And we see all of those showing up here in the search output. And then you can just select to go directly there. We've added modules in JDK 9, so this also works over modules. For instance, if we look for the base module, it shows that as a module result, and we can also look over the packages in that module. We usually use camel case naming convention in Java, and sometimes the method names are kind of long. So let's say we wanted to find out the Javadoc for equals ignore case. We could type that whole thing out, but that'd be a little inconvenient, so we can use camel case search instead. So we can go equal, and then IG for ignore, and now we can select which of the 2 methods we want there. So it's a nice, quick way to look up information in Javadoc now. So less often you'll be tempted to use a search engine to find things in Javadoc. You can just use Javadoc itself. The search feature is implemented client-side in JavaScript, so it's runnable locally. You don't need to have a server to do this. As I mentioned, it indexes over all sorts of names and signatures present in the Javadoc, from type names to the module names. You can also, using a new tag, define your own index terms that will show up in the search. The next 2 features I'll talk about concern transitioning from one JDK release to another, multi-release jar files, and the javac -- release flag. So first will be about cross-compiling with this new -- release flag. So javac's long been a cross-compiler. You've been able to use javac to compile from the current JDK back to older ones. I've written a blog entry about how to do this. It's also in the javac man page. And there are 3 things you have to set for your javac command to make this work properly. You have to set the source version you're using. You have to set the target version. And finally, you have to set the boot class path to the boot class path for the earlier JDK release. Related to this, we've changed the policy about how many source and target versions we support. Instead of going all the way back to the beginning, we now have a version of 1 plus 3 back. We started this in JDK 8. So for JDK 9, that means for source and target, we support 9, 8, 7, and 6. However, 6 is deprecated, and a warning is issued when we use it. So following this policy in JDK 10, the 6 option isn't supported anymore, but you have 10, 9, 8, and 7 is deprecated, and so on. So why do you need to set the boot class path? Well, let's take an example here of the JDK library. In JDK version n, there's one method foo that takes a double. And let's say in JDK n+1, an overload for foo is added that takes an int. And let's assume that these are semantically equivalent, but it's just a fast pass for int, so that it would follow all the usual behavioral, compatibility rules we care about. So this is a perfectly reasonable library change for the JDK. Now let's have our client library that calls foo. So if we take the client library here and compile it against JDK n+1, what does the call of foo mean? So foo here takes an integer argument. So then if we go over to JDK n+1, which of the two foo methods is going to get put into the class file? Is it going to be the method that takes a double or the method that takes an int? It's going to be the method that takes an int, right? That's the most specific method, and that's what the spec says to have. So let's say we take that class file, even if it has the class file version for the older JDK N version, and now we run it against JDK N. What's going to happen? We're going to get an error something like this at runtime. No such method error. Now, if we decode what the error message says here, it basically says, I'm looking for a method foo in the library class that takes an integer. That's what the I in parentheses means. And of course, in JDK N, there is no such method, because we only have the method foo that takes a double. Now, to avoid this sort of mismatch, this is why you need to use the boot class path from the older version when you're cross-compiling. So we've known about this problem for a while, and people would keep reporting bugs about it. And we figured, all right, well, we'll provide some help. In JDK 7, if you use the older source or targets and you don't set the boot class path, we'll issue a warning. And you can suppress the warning if you want. So that's fine. We thought that would prevent people from running across this problem. But we were a little too optimistic about that. We still had bugs coming in about this. So we thought about it some more. And for JDK 9, we thought, you know what? We know what people want to do here. They just want to cross-compile to the older version. So why don't we provide that functionality directly instead of having people to approximate it themselves? So that's exactly what we did with the -- release and option. That's semantically equivalent to specifying the source, target, and boot class path. And now that boot class path information is provided to javac stored in a compressed form. As an additional bonus, the information available in release n is only the APIs we think you should be calling. So those are the Java SE APIs and the exported APIs of the JDK. So things like those tempting sun.star APIs are not covered in there. And for -- release, you have the same set of options as for source and target. So a few advantages here. If you were setting the boot class path previously, you don't have to worry about managing that artifact anymore. Where do you get the boot class path from? Some people use the Maven plugin Animal Sniffer. Any people use that plugin? One or two hands. So that did the same sort of checking. That shouldn't be as necessary anymore because it's built right into javac. It also means that if you use a javac from newer releases, you can take advantage of bug fixes and some possible performance improvements that might have gone on since the earlier JDK. Another feature we've added to help ease transition to newer JDKs is multi-release jar files. So if you have a library and application, it would be inconvenient to have to distribute a jar file, one for JDK N and another for JDK N+1. So people instead will distribute a single jar file, you compile against the oldest JDK they want to run on. That has a few consequences. It does slow down the adoption of new features because it's awkward to use the features in the newer JDK. Sometimes you can get around that using reflection, but that's slow and somewhat awkward. And the modularity features in JDK 9 make some of those, you shouldn't be using them APIs, harder to access. So this wouldn't work quite as well. So the alternative we added now is multi-release jar files. The idea is pretty simple. There's a common shared area across all versions. But then under the meta-inf area, there are JDK platform-specific overrides. You could have overrides for, say, 9 and 10 that take advantage of 9 and 10 specific functionality. The multi-release jar files are created using new options to the jar command. And the parts of the platform which consume jar files, the jar API, the Java command, and javac have been updated to be multi-release aware. Next, I'll talk about some of the language changes, non-modularity language changes that have gone into JDK 9. The first of those would be in milling project coin. So the term milling a coin refers to putting those little ridges around the edge of the coin, as shown in the silver dollars here. The motivation for this was when coins were generally made of precious metals like silver or gold, people tend to shave down the edges of the coin and then sell that separately, kind of debasing the coin. And by putting the ridges on the coin, it makes it more obvious that that's going on and preventing that. So in the same idea for milling project coin, we want to maintain the value of the coin features over time by filing off some rough edges that were left at the end of the JDK 7. As a reminder, these are the project coin features from JDK 7, and 3 of them will have small updates in JDK 9. These are the updates we'll be talking about. 3 of them are for project coin. There were some similar situations for Project Lambda where they had a few leftovers to take care of, and those were handled under milling project coin as well. So the first of these changes we'll talk about is safe var args on private instance methods. So back in JDK 5 or 6, you might have written code like this. You have a list of strings, and you want to initialize it using arrays.asList, one of the platform methods, so that should be fine. So you have January and February in English and Italian here. So then if you did a compilation of this, you get a warning like this. Warning, unchecked generic array creation from varargs parameter of type list of string array. So this message sounds a little concerning. What's going on here is basically a bad interaction between arrays and generics from the varargs parameter of arrays.asList. And the language specification requires a warning be issued in this situation because something called heap pollution might be going on. There might be a misleading, the compiler can't prove that things have the proper type. So while it's correct in the sense of you want to warn when this situation might possibly occur, nothing bad actually happens in this case. So this is a false positive and the error is uninformative. So we prefer not to have these false positive errors when we don't have to. So for that reason, we added this safe var args annotation back in JDK 7. And safe var args basically says, compiler, please trust me. I'm swearing that nothing bad along those lines is happening in the var args method, so you don't have to issue the warning. And we added this annotation to a number of the platform methods, including arrays.asList. Now this annotation does a few things. It removes various warnings from the method declarations, but more importantly, it removes warnings from the method call sites. That is all the uses of these methods. So users wouldn't get this uninformative warning message anymore. Now, because of the design of annotations, annotations are only inherited for classes, not interfaces or methods. That means we can only use the safe varargs annotation on methods that can't be overridden. So what are the kinds of methods in Java that can't be overridden? We can't override final methods. We can't override static methods. We can't override constructors. Because from a certain point of view, say at the VM level, a constructor is just a very special static method. It has the same kind of feel to it. But there's a fourth kind of method you can't override, and that is a private method. And we forgot about those when we were doing Project Coin in JDK 7. So in JDK 9, now we added them. This is the corresponding part of the Java language specification, and we were just able to add 2 words to cover the language change here. So this is a very small language change. We like them when they're nice and simple like this because they're often much more complicated and surprise us. But there were no surprises here. Next, I'll talk about effective final variables and try with resources. So as a reminder, you'll be familiar from using JDK 7 or 8, you have try with resources. So you have your resource R in a block, and now you manage it. And this is roughly equivalent to this, where The compiler inserts a try finally around your block, and it makes sure that close gets called on your resource if the resource is non-null. It's actually a bit more complicated, this, about exception handling. So in terms of full disclosure, this is the full distributing here, which is more involved, but we don't have to worry about this. The compiler takes care of it for us. So what's the structure of the resources to be managed? In JDK 7, the rule we ended up with was you had to declare a fresh resource variable for the resources managed by the try with resources statement. That wasn't the original proposal. Originally, you could pass in any expression that had the right type, and the type being auto-closable, meaning that the object in question had a close method. But we found a problem with that. So let's say we have a resource R, and then we manage R with the try with resources statement. And within the block of the try with resources statement, we make R point to a different object. So what should happen now when we get to the end of the block? Which object should have its close method be called? Should it be resource 1? Should it be resource 2? Should it be both of them? We decided we preferred not to solve this problem. And the way we didn't solve it was to not allow you to just pass in an arbitrary expression. But you have to have a fresh variable that had to be final. So that was a little, so that worked, but it's a little annoying to have to declare a fresh resource variable, because there's some times when we know this situation can't occur. You can't reassign the variable if it's final, and you can't reassign it if it's effectively final. Effectively final means you could declare it final, you just haven't gotten around to doing that yet. So what we do now in JDK 9 is we allow you to use an existing variable as long as it's final, effectively final. So instead of writing code like this here, where we have to have this second resource just to manage the try with resources statement, we can just pass the final variable R right in there. And this works fine. We avoid that problem of not knowing which object to call close on. This wasn't too hard to do at a grammar level. We just expand the grammar a little bit to allow variable access. And the specification change corresponding is here. Now, you might initially think that this would be a very small spec change, just a sentence or two or a few words, because maybe you just want to call, allow, say, a local variable that's final, effectively final. But we don't want to allow just a local variable that's final, effectively final. We want more orthogonality between the features. So even if you have something like a final field of a new object from an anonymous class, that should be allowable too. And that's what this change allows. So diamond with anonymous classes. So diamonds are formed under the earth at great depth and pressure, and we'll have to go a little bit down the rabbit hole to see what's going on here, but it's hopefully worth the trip. So I'll be using this example of a box type for the next few slides. You can think of a box as a simplified collection. So it's a parameterized type. You can put objects in and get objects out. And so we have an example here. We have list of question mark. That's a wildcard type. And let's say we want to put that into our box and using diamond. So that's fine. Now, what the compiler has to do at this point is infer what goes between the angle brackets. So Java is still a statically typed language, even if it's not explicitly typed. What that means is if we as programmers don't put in the types for the angle brackets of the parameterized types, the compiler has to do that work on our behalf instead. And the process by which that's done is called type inference. So inside the compiler, what happens is it infers this type list of capture of question mark. Well, this sounds a little unfamiliar. So what's going on here is that this is something called a non-denotable type. This is not a type we could write ourselves in the program. However, it is a type available inside the compiler. This is actually a fairly common implementation technique for compilers where there's a richer type system inside the compiler than is directly available to programmers. So capture conversion, this is a type operation. And basically it means inside the compiler, each of the wildcards, each of the question marks, which means there exists some type, is replaced by a new fresh type variable inside the compiler, some particular type variable. So it's converted from a wildcard, captured, given a particular name. This is described in the JLS. And if you're interested in this sort of thing, if you're reading this part of the Java language specification, it's good to have a type theory manual nearby. Now, boxes as a class, it can be subclassed, including being subclassed anonymously. Again, we want our features to interact and be orthogonal. But this anonymous subclassing is a bit of a problem for Diamond, as we'll see in the next slide or two. So let's say we wanted to compile this anonymous subclass. How would that look? So it's a class, so it needs a class file, so it'd have a name something like box $1. And as a class file, it has to be translated into a class file with a full set of attributes. So in particular, the generic information about a class is put into a signature attribute in a class file. The signature attribute only can hold denotable types. The grammar for signatures doesn't allow non-denotable types. So the grammar does not allow for list of captures ? In particular. So this was rather unfortunate when we realized this in JDK 7, because this is now a problem. We can't write out a class file that has the information needed. So what's happened here? Well, we've had language interactions over time. Way back when inner classes were added in JDK 1.1, generics were added in JDK 5, and generics and inner classes interoperate just fine. We made sure that occurred. Then in JDK 7, Diamond was added. So pairwise Diamond and inner classes work just fine. And pairwise Diamond and generics work just fine. After all, that's what we're trying to do. But if we combine Diamond, inner classes, and generics, we have a visit from Fang. This is Duke's evil twin brother who's looking to deface coin with our battery acid here. So this is a case of today's problems coming from yesterday's solutions, as our language architect Brian Getz liked to say. So as a result of when we found this in the JDK 7, we had to have a quick solution, and we decided just to not allow Diamond with anonymous classes at all. We thought that was a little unfortunate, and when we were finishing up the JSR, we did note that it's feasible that future platforms, we could allow use of Diamond when creating anonymous inner classes, as long as the inferred type was denotable. Basically, as long as that bad case didn't happen, there's no reason we couldn't use Diamond. And that is indeed what we've done now in Java 9 to allow Diamond with anonymous classes as long as the inference works out fine. This is the spec text needed to do that. It's a little involved, but luckily we have the spec guys to do that for us. Diamond in JDK 7, by our experience, was quite effective. It was able to get rid of about 90% of the explicit type arguments at constructor call sites. And we think with Diamond and anonymous classes in 9, we can get rid of much of the remaining 10%. We've had good experiences updating the JDK code base to use this, in particular, these calls to privilege action. Next up is underscore no longer an identifier name. This has been a change unfolding over a number of years in releases. Part of Project Lambda in JDK 8 was not allowing a single underscore to be used as the parameter name for Lambda. This was to avoid confusion with the wonderbar feature of other languages you might have used. And while in JDK 8 it remained legal to use a single underscore as a name in other contexts, you did get this warning from Javac letting you know that this might be going away. And indeed now in 9, it has gone away. So why would we do this? This is against our usual compatibility policy of keeping the program that compiles today compiling tomorrow. We want to reclaim an underscore for a single underscore for some other purposes going forward. There are a few potentials there, maybe a partial diamond, maybe a partial witness, or an official way to say a don't care or variable not used warnings to get rid of them. And some more particular uses are being discussed under one of the JEPs for upcoming JDKs, under JEP 302, part of a more Lambda leftovers work. Next, private on interface methods. Again, these are another one of the Project Lambda cleanups. Project Lambda added default methods to interfaces, that is, methods that can have bodies, so they're non-abstract. Now, at the VM level, it was convenient and necessary to have private methods in interfaces to help implement these. However, private methods on interfaces were not valid at the source level in JDK 8. So now we've changed that in JDK 9. You can have both private instance methods as well as private static methods. And why would you need these private methods in an interface? You can have them as helper methods for the other default methods. So they're quite useful for that purpose. Next, I'll be talking a bit about deprecation and imports. This was one of another few small language changes. So as a background, a few years ago in the JDK, say at the start of JDK 8, we had some unpaid technical debt. we had over 10,000 warnings of our own code from our own compiler. So that wasn't a great situation to begin, and over the years we worked hard to not knock down those warnings. So toward the start of JDK 9, we had about half as many, about 5,000. And between the start of JDK 9 and about build 47, we went down from a few thousand warnings all the way to 0. So we were quite happy about that. We turned on excellent WError in our build, and this covered our open code, closed code, and all the other code in certain parts of the platform. Now, if you look at our Mike files today, this isn't quite true anymore. There's still a few dozen. It was true for some time. It was true for many builds. But we currently have a few dozen warnings remaining of a new in 9 category. So we haven't quite gotten around to fixing those yet, but maybe after the conference I'll be able to fix those in 9. And those warning-free or mostly warning-free modules include the base module, desktop, and core things like the compiler. We didn't get around to covering other parts of the platform. So people often talk about technical debt. I'd also like to talk about technical dividends. There's some benefits of doing this. Since we have the serial warning, we don't have to worry about forgetting to declare a serial version UID. There's an equals hash code check from javac to make sure you're overriding one when you do the other. There's possible security benefits. The go-to-fail security issue from a few years ago is similar to having an unintended switch on a fall-through, and that is one of the conditions checked by javac errors. And in that diagram, the very lowest bottom level was about deprecation. So is it really acceptable to have deprecated items? And I've written up some advice if you want to try to remove the javac errors from your own code base. So deprecation errors. We had hundreds of them. There are a few ways you can resolve them. You can remove use of the deprecated element. That's preferable in some ways, but you can't always do it. You might need to keep exposing that functionality for your clients. You can propagate the deprecated annotation to the use site. Now, in some ways, the cure is worse than the disease, right? Because you're expanding rather than contracting the amount of code that's deprecated. So the last thing you can do is you can use the suppress warnings annotation to declare that, yes, I know I'm doing it, but don't warn me about it. It's OK. So let's see how you might use that. You have your client code. You have your deprecated library. So when you compile, you get this warning. Say, fine. I don't want to make this deprecated itself, and I have to keep using the deprecated library, so you'll just apply the suppress warnings annotation, like so, right at the top of the class. That looks good. So then you compile again, and you still get a deprecation warning. So what's going on here? Well, if you look at it a little more closely, what's going on, you're actually getting a warning in this case from the import statement, because you're importing the deprecated library. This warning is mandated by the JLS. Now, you might say, well, that's not a problem. I'll just apply another suppress warnings annotation on the import statement. You can't put the annotation there. It's not syntactically valid. So this warning, it's well-intentioned, but it is kind of unhelpful, because if you can suppress all the other uses of the deprecated type, why do you get this warning from the import statement? And you shouldn't have to do something like change to using the fully qualified name everywhere to get a warnings-free program. That'd be a little silly. So we changed the language specification in 9 to not require a warning in this situation. And with that, it's now tractable to clear a large code base of deprecation warnings, and the existence proof for that is the JDK code base itself. So there's more changes to deprecation in JDK 9. What does deprecation mean? It's been around for a long time. Does it mean it's harmful? Does it mean it's going away? And if it does mean it's going away, why haven't you JDK guys removed anything, or just removed 1 or 2 things after all these years? Well, we needed a richer set of tools to help manage this, and we did that by changing the deprecation annotation in JDK 9 to have more information. In particular, we added a method that says for removal that's Boolean, whether you plan to remove it or not. And what this means to the types we've applied it on in javac on the JDK, if something is deprecated for removal true, we intend to remove that item in the next major version of the release. So the items that are deprecated for removal true in JDK 9, we plan to remove in JDK 10. Now there's a new lint category for this, removal. That's the category we haven't quite finished cleaning up yet in our own code base, so that there's an extra warning if you're using a for removal true item as opposed to just a normal deprecated item. There are updates for this throughout the platform. from the language spec, javac, and Javadoc. There's also a new static analysis tool, Deprecation, that will analyze your class files and jar files and let you know when you're using deprecated APIs and deprecated for removal APIs. So you can clean that up on your own without recompiling. Finally, I'll give a brief overview of some of the library updates that went on in the release. First, there's a new version string scheme. Basically, for many years, we've had 1.5, 1.6, 1.7, 1.8. You'll notice the 1 dot's never changing, so we decided since it's not changing, there's no reason to have it around, so we dropped it. So now the version from JDK 9 will be something like 9 instead. There was some interesting work done with strings in JDK 9. There's a new internal representation for compact strings. They use a byte array instead of a char array, so they're often denser, so better memory usage, less garbage collection, and the like. There's also a separate effort to provide a communication channel interface between a Java compiler and the VM to have better string concatenation. The shapes of string concatenation a Java compiler emits, and the shapes that a particular VM can make run fast can change over time, and this is a stable point that can be used to get better performance on that common operation. A few notes on collections. So how many times have we written code like this? You want to have a set of strings that's unmodifiable, so you'll get a hash set, you'll put a few things into it, and then put it in the wrapper. This is kind of taking up a lot of space for what it is. So we might do something like this instead. We use arrays.eslist, and then we have the wrapper there. It's shorter, but it's still kind of long. There are other coding techniques you can use, the double brace trick with the anonymous class. I won't even show that. But this is still rather clunky for a very common operation. So in JDK 9, we don't have to write code like this anymore. We can just write code like this, which is much nicer. There's static factory methods of added to list, set, and map. These return unmodifiable collections. Maps and lists have randomized iteration order. And my colleague, Stuart Marks, who worked on this feature, will be talking about this and other collection changes in JDK 9 later this afternoon. Java util objects is a type that has various utility methods. We expanded that as well to have some additional options for checking for null and checking for indices, very common. If you're interested in math, as I am, we had a few changes there as well. Fuse, multiply, add, which is a hardware instruction for floating point that's getting more and more common. If you do things like lexicographical array comparisons, we now have intrinsic support, so we can use hardware instructions to make that go faster on platforms with that approach. Also changes in concurrency and var handle for more advanced programming. Lots of other changes too. That was just a few highlights. So in summary, in JDK 9, we're making fundamental changes to the programming platform with modularity. But we have many other changes as well. And modularity and the other changes are geared toward encouraging the long-term evolution of the platform. So Duke here in the US is of legal drinking age. Java's been around for over 21 years, and we want Java to be around for many more decades to come after this. Some of these language changes and other changes are planned and unfold over multiple years and multiple releases, and we have better tooling now to help manage that transition, both for ourselves and for Java users. This is being done in OpenJDK, so if you want to get more involved, you're welcome to follow there. And those early access builds are available today for your evaluation. So please try out the JDK 9 early access bits. This is a URL to the slides here. We have time for some questions now, and you can also tweet questions to the hashtag on the final slide. Thank you. If you have a question, please come up to one of the microphones in the aisles.
My question is, did you consider array slicing for 9? And would you consider it in the future?
Array slicing? Could you say what you mean by that?
Like in Python, where you can just slice up an array by using syntax of the language.
The question was, did we consider array slicing? That was not considered. There are more array-based changes coming, but I don't think that one is one being discussed. All right, I'll be down here if there are other questions. Thank you for coming here today.